So I'm speaking directly to my audience. Sometimes it's a few hundred of you, sometimes thousands. Many of you have actually tried this setup yourselves and confirmed that it works. You've seen the results, you've shared your success. So this message is for you, not for those trying to argue without ever testing. Let's look at what Colin is doing here. Colin is repeating the same argument over again without addressing the key factor I've clearly shown. There are two charge controllers in this system, one connected to the battery supplying amps, and the other managing the solar panel receiving light from the LEDs, where Colin's logic breaks down. He's assuming a closed loop like this. LED, solar panel, LED. And from that, he says, you can't get more power out than the LEDs consume. But that's not the setup. Here's the real configuration. Battery charge controller 1 LED light solar panel produces voltage. Solar panel, voltage, plus battery, amps. Charge controller 2 output, usable power. So what's happening? The battery provides the amps, the actual energy source. The LED lights just shine on the solar panel, causing it to generate voltage. The second charge controller takes the voltage from the panel and combines it with the amps from the battery to deliver real wattage, volts times amps, to the output. Why people like Colin keep getting it wrong? 1. They assume this is just an LED lighting a solar panel in a loop and ignore the battery. 2. They don't understand that the solar panel can act as a voltage trigger, not the full power source. 3. They repeat the usual that breaks physics line without listening to how the system actually works. 4. Most importantly, they never build it. They just argue theory. And that's the real problem. He's not trying to understand it, and he's not going to build it. Instead, he's trying to convince you not to. That's why we keep showing you test videos, real builds, and feedback from people who succeeded. You don't have to guess anymore. It's out there. Maybe one day, people will stop blindly repeating what they were told and start testing for themselves. When they do, they'll see what we found. Energy that's clean, self-sustaining, and free. At this point, instead of going back and forth with someone who clearly isn't trying to understand, and that's my honest belief, we're just going to keep showing you real people who've actually built this. Not just me, others. Eventually, the truth becomes too big to ignore, and more people will try what's already been done, even though the industry won't talk about it. The principle is simple. When you're mixing amps and voltage from two different sources like two panels or a battery and a solar panel, each connected to its own charge controller, you can combine those outputs into one usable system. That's not theory. That's just how electrical math works. And as soon as your output wattage, volts times amps, goes above the wattage needed to run the LED lights. End of discussion. The numbers speak for themselves. So now, let's stop debating theory and watch someone who actually built the system.
An update on the circuit. So I'm running 4 batteries. So the first battery is this one. This one is being used as solar panel at night. Okay, the sun is coming to the solar panel at the moment, but we can do this test to see what's happening. So forget this, the solar panel, just focus on the battery. The battery is providing 12.2, 2.68 amps, 2.6 amps, okay, and that's what's coming into the solar system. So it's coming through here on this one, 12 volts, 11, it boosts to 73, goes in here, then 24 or 25 goes in there, boosts to 80, goes in this one, it's charged, 39 goes in there, boosts to 80, charged this battery. So this one is this one. This one is a 24 volt battery in the back, which is this one is a 200 amp hour 24 volt battery. And the first battery, it's also 24 volt battery, but it's 100 amp hour battery. Okay, so this is the setup behind the circuit, and I'm gonna disconnect this battery I'm gonna disconnect the battery, and it reads more because the battery has more volts, but it's charging, it's rebooting the circuit, and it's providing me 25.3, but the amps, there's no amps. So since there's no amps, this one changed from from float to bulk. Changed from float to bulk. So it is losing energy after I unplug the battery. So this battery can run all night, powering the circuit. So charging the circuit. These ones, they are charged because they are getting the energy from this battery, and this battery is providing energy to this one, to the 36. So the 24 volt is supplying energy to the 36 volts. That's why it's not on float, because there is not enough energy coming from the solar at the moment. As you can see, there's not enough sunlight. But as soon as you connect this one into the circuit as a solar panel, because it has amps, it's gonna change this one to green. So I connect it. So the 13, 12.8, 12.9, and it's still charging because it discharged a little bit. And also, I'm charging this power bank, and also the LED strip lights are running all night, so 24 hours a day. It's hard to see, but yeah, they're running 24 hours a day, providing energy into this battery. So it's coming from this junction here. You see this wire is the LED strip lights connected to the battery. This one is for a different thing. This one is not connected here. This one is not connected here. The transformer is not connected here. But if I connect the transformer to the load on the output, it will make a loop, and the battery will have 13.9, 13.7, something like that, to power the circuit. Oh, so as you can see, it's on float mode now because it has the amps from the battery. So during the night you have these amps, and you can charge your solar system completely during the night without sunlight, just through a battery that has amps. And also, this is important, even though it doesn't seem to be important, it gives you the volts to maintain the volts on the battery, so the battery doesn't discharge as much as if it was not using anything. So this is the circuit.